You ever wonder how your food delivery app knows exactly where your driver is? Or how all your smart home gadgets just talk to each other? Like magic? Well, a lot of the time, the secret sauce is something called an API access key. They're these invisible connectors that make our digital world go round. But they're also a massive security risk. So today, we're going to pull back the curtain on this powerful, double-edged sword.
I mean, think about it for a second. How do all these different pieces of software, built by different companies, all communicate with each other safely and securely? From the apps on your phone to the massive cloud services that power them, it all feels so seamless. But behind the scenes, there's this constant, complex conversation happening. So, how does it all work?
Well, in a surprising number of cases, the answer comes down to this one simple, yet incredibly powerful tool, the API access key. You can think of it like a digital passport that lets one application prove its identity to another. It's a really simple idea, but as we're about to see, the implications are absolutely huge.
Okay, now before we dive in, let's get one quick thing out of the way, because this can be a little confusing. If you've done any web development, you might have heard of the HTML access key attribute. That's a keyboard shortcut for things in your browser. That is not what we're talking about today. We are focused on the other kind, the API access key, the one that's all about authenticating services. Just wanted to make that super clear.
All right, so let's get right to the heart of it. What exactly is this thing we're calling a digital gatekeeper?
At its core, an API key is basically an ID card for your application. It's a unique string of letters and numbers that says, "Hey server, I'm app X and I'm supposed to be here." Now, the really important thing to understand is that it's not identifying a person like a username and password would. It's identifying the project or the application making the request. And that's a crucial distinction.
And this is where it gets really powerful. See, an API key isn't just a simple key for a door. It's more like a super smart access card. For the service provider, it's a multi-tool. It's how they control who gets in. It's how they monitor how much each app is using their service, which is key for billing. And it's how they stop one buggy app from taking down the whole system by making too many requests. That's called rate limiting. The key lets them track usage, set limits, and, if they have to, block an app that's causing trouble.
So, these keys are incredibly useful, right? Absolutely. But here's the twist. That simple little string of text is also one of the most common ways that major, catastrophic data breaches happen. This is the double-edged sword we mentioned, and now we're going to look at that very, very sharp edge. This quote from Strapi just puts it so perfectly. A single leaked key can grant attackers extensive access to your sensitive business information. Just let that sink in. It's like building the world's most secure fortress and then leaving the master key under the doormat. A leaked API key can literally be that master key.
So how in the world do these keys end up in the wrong hands? Well, you might be surprised. It often boils down to really simple, totally avoidable mistakes. A developer might paste a key right into the application's source code. We call that hard coding. And then even worse, they might accidentally commit that code to a public website like GitHub. And trust me, attackers have bots scanning these sites 24/7, just looking for that exact mistake. Even something as innocent as sharing a key in an email can lead to a total disaster.
So let's just walk through a classic breach scenario. It starts with an honest mistake. A key gets exposed, maybe in that public GitHub repository. Then an attacker's automated scanner finds it, sometimes in minutes. Just like that, the attacker uses the key to get unauthorized access to cloud services, databases, you name it. And before anyone even knows what happened, boom, sensitive data is gone. It's a scary and frighteningly fast chain of events.
Okay, so that's the scary part. But here's the good news, and it's really good news. This is a solvable problem. So now we're going to shift gears from the risks to the solutions. It's time to learn the essential best practices for properly locking down your keys.
The absolute #1 golden rule is this. You should never, ever, ever store API keys directly in your source code. So the obvious question is, if not there, then where?
You've got a few great options. The most common one is to use something called environment variables. This basically means the key lives on the server itself, totally separate from your code. For more complex setups, you can use a dedicated secrets manager like AWS Secrets Manager. Think of it like a high-tech digital vault just for your secret keys. And another really clever approach is to use a back-end proxy, where your public-facing app never even sees the key. It just asks your own private, secure server to make the call for it. All right, next up is a core concept in all of cybersecurity, and it's absolutely critical when it comes to API keys. It's called the principle of least privilege.
The idea behind least privilege is actually super simple. A key should only have the bare minimum permissions it needs to do its job, and absolutely nothing more. So if your app only needs to read data, its key shouldn't have permission to delete data. Make sense, right? You can also lock keys down so they only work from certain IP addresses. And here's the big one. Never use the main root account key for an application. That's like giving an intern the keys to the entire company headquarters. Just don't do it.
You see this number? 90 days. You should probably burn that into your brain. That is the recommended maximum lifespan for an API key. Why so short? Well, think of it this way. If a burglar somehow got a copy of your house key, you'd want to change the locks as fast as possible, right? It's the same idea. By regularly rotating your keys, you dramatically limit the window of opportunity for an attacker if a key ever does get compromised. So how do you actually rotate a key without breaking your app? Well, you definitely don't just delete the old one and plug in the new one. That would cause an outage. Instead, you follow this careful 5-step dance. First, you create the new key. Then, you update all your apps to start using it, while the old one is still active. Once you've checked and validated that everything is working perfectly with the new key, then you can go ahead and deactivate the old one. And finally, you delete it for good. It's a smooth, zero downtime transition.
Now, as important as all these best practices are for securing our keys, the truth is, the entire industry is starting to move towards an even better, more secure model altogether.
This quote from the AWS security blog really gets to the heart of the matter. The very idea of a long-term static secret, like an access key that never changes, is itself a risk. No matter how well you protect it, it's still a secret that can be stolen. And that's why the modern approach is to get rid of long-term secrets entirely.
And this slide really lays it all out. On the left, you've got the old way, the long-term access key. It's static, it's high risk, and you have to remember to rotate it manually. On the right, you have the new way, temporary credentials. These are dynamic, they're incredibly short-lived, we're talking minutes or hours, and the system rotates them for you automatically. The security benefit is just massive.
So the big takeaway here is that for most modern cloud workflows, you often don't even need a static access key anymore. There are better, purpose-built alternatives. If your app is running on a cloud server, you can use something called an IAM role, which hands out temporary credentials on demand. If you're a developer working in the command line, tools like IAM Identity Center can do the same thing. The future is all about short-lived, automatically managed, temporary credentials. So we'll leave you with this question to think about. After everything we've covered today, from the hidden dangers of a key in your code to the power of temporary credentials, take a moment and think about your own projects. How secure are the keys you're working with? Are there secrets hiding in your source code? Are they being rotated? The simple API key is a fundamental building block of our connected world, and securing it properly is a responsibility that we all share.